Okay, so hello everyone, welcome. Can you hear me? Hello.
Yes.
Yes, sir.
Yeah, okay, thanks. Okay, just we are waiting 1 or 2 minutes, then we'll start. Okay, so we'll start our presentation. So basically today is our third number of class. And for after completing this today's session, then we talk about the problem solving for the previous class. Okay. Okay, so let me share my screen, then we'll start our today's session. And can you see my screen? Is it visible? Okay, can you see my screen?
Yes, sir.
Thank you. Okay, so continue. Okay, let's go. Want to join this online training program on Google Earth Engine for 7 days. So you can simply complete your registration. For that, you can simply contact in this WhatsApp number, as well as you can also contact with this email. So I already add all of those things in the video description. Then you can simply check it, and then you can easily join our upcoming batch online training program. So basically, this class will be start from then 17 May, and admission last date is the 15 May. And first 10 registered people will get the 50% discount on this online training program. And basically, in this online training program, you will learn all of those things which you need to start the journey with Google Earth Engine platform. If you have no knowledge about the coding, mainly JavaScript or Python, don't worry about that. In this online training program, you are able to learn all of those programming languages such as JavaScript or Python. So here you can see I already added all of those course content, mainly what you will learn after completing the total 7 days online training program. If you want, you can also check all of details from my video description. I already added all of things in my video description. So when you want to join this live training program, you can get some benefit after submitting all of assignment. You can get the course certificate. You can get that all of materials, mainly slide PDF. You can get all of practice code. Okay. And you can also get the recorded class. Suppose if you miss any live training session, you can easily cover using the recorded class, as well as you can also get the lifetime teaching support. It's very important as a beginners, because when you want to face any problem regarding any issue in your code, you can get the lifetime teaching support. Okay. So if you want to join this live training session, you can simply contact in this WhatsApp number, as well as also contact with this email, and get the 50% discount. So book your seat as soon as possible. After booking your seat, you can able to join our Google Classroom and also join our WhatsApp group. So thank you. Okay, so basically today's I will try to discuss about this type of topic, mainly calculating any indices from satellite images, Landsat or Sentinel image, as well as how we can easily filtering the Sentinel-2 satellite imagery. Previous class I discussed about the Landsat, but today's session I talk about that Sentinel-2. How we can easily filtering the Sentinel-2, and further how we can easily monitor the NDWI. And from the NDWI, how we can easily extract the water body from this NDWI using the different types of thresholding value. As well as we talk about that time series chart. Okay, so basically previous class we discussed about the ready-made data set. Today's session I talk about that unready-made data set. How we can easily make the NDWI or NDWI or Sabi, or any other kinds of indices, how we can easily make the time series chart. We also talk about that. Okay, and how to export shapefile, it's already done. How to gradient legend on our title, on our map, we talk about that. And NDWI calculate from modis or Landsat data, we also talk about these things. Okay, so let's jump our class. So just I simply open my slide. So basically, when you filter or visualize the satellite image in Google Earth Engine platform, Landsat or Sentinel, approach is the same. Okay, first of all, you have to select your study area. Then you have to filter your image properties. Then you have to filter the image time period. Suppose I need this Sentinel-2 satellite image for the Dhaka city. Okay, so first of all, I need to import the boundary shape file of Dhaka city. Okay, so this is my first filtering factor. Second factor, you have to filter the image metadata. Suppose I need only for those images which image will not more than 1% cloud cover. So it's the another factor for filtering image collection. And thirdly, we have to filtering the image time period. Suppose I need the image for the rainy season, I need the image for the summer season, I need the image for year of 2017 or any time period. So basically, when you filter any image collection, it can be Landsat or it can be Sentinel or any other image collection. First of all, you have to filter according to your region of interest. Then you have to filter according to the image properties or image metadata. And finally, time period. Suppose I need this image for year of 2017 month of January. I need the image for year of 2017 summer season, rainy season, or any specific time period. Okay, so let's do practical example. I try to show you that. Just I simply, okay, I already opened the code editor. So first of all, I need to import the image collection. So for that, I simply click on the browse data catalog. Here I find out all of image collection. In this time I work for the Sentinel. So just click on the Sentinel. I want to work for the Sentinel-2 multi-spectral instrument. This image collection I want to use. So just I simply click on here, then I can get all of information. Basically here you can see surface reflectance or top atmospheric. Okay, basically both of image collection is the same process for filtering and visualizing. I want to show suppose top atmospheric. So in this time, this is my image collection about the Sentinel-2 multi-spectral instrument level 1C, and we can get the image from year of 2015 to 2024, 25 April. Okay, present time. And here you can see this is that art is a snippet. So basically it's the unique ID of this data set. And here you can check all of description about this data set. Also you can see about the bands, all of band B1, B2, B3, all of band we can easily get from here. Also you can get the image properties. So in this time, this image collection I need to import in my code editor. So just I simply copy, same process we are applying. Simply copy this unique ID and paste in our code editor. Okay. And further give a variable name. In this time you can put any name, but before variable name you have to define the var keyword. So just I take a variable name. Suppose I put the name is that Sentinel 2. You can put any name as a variable. So now this full image collection is stored in this variable. Okay. So suppose in this time, this image collection, I want to filter 2 season. Suppose rainy season as well as also summer season. I want to filter the 2 time period. I need the 2 time period image for rainy season and summer season. For this time, I just take a variable. Suppose I put the variable name is that suppose dry image or dry season image. You can put any name. I put the dry image, and now this is my full image collection. Okay, so I simply call the Sentinel-2. Further, I want to filter it. Okay, so this image collection where I need this image collection. Suppose Dhaka city or Dhaka city boundary shapefile. I need this image. So for that, I simply imported the Dhaka city boundary. Here I already imported this shapefile of Dhaka city boundary. I simply import, and it shows the default name as a table. I change it. I put the name as a suppose RY. You can put any name. Okay. Further, I just simply put here the filter bounds with my study area, which is ROI. Okay. Basically, Sentinel-2, it stored the full image collection, but in this time, I need this image collection only for the Dhaka city boundary. So for that, I simply put here the filter bounds with my study area. Okay, it's done. Further, I want to filter the image metadata. So for that, simply use here that filter metadata and put here the 3 argument name, operator, value. So name mainly image properties name. Suppose I want to filter using this image properties name. You can see cloud pixel percent. I simply copy that properties name and further paste here. An operator, I simply select the operator, suppose less than 1. Suppose put value for 1. Okay. So in this time, I choose only for those images which image is the less than 1% cloud cover. Okay. Further, I want to choose, I put a filter date function and put the time period for summer season. Suppose I put the summer season for 2020. I put here, suppose year of 2020, January, 1st January. Suppose from year of 2020, April, suppose 30. Okay, I just put this type of time period. Okay. And now further, you can see when I just check how many image collection is available about that, I simply copy the dry image and use here the size function. It show me how many image collection are available for this condition. For my Dhaka city region of interest, less than 1% image, and also this time how many image collection is available. So now it's computing. We can get the 20 image collection about that. So in this time, suppose I use the another function. In this time, I don't use the filter metadata function. So basically, filter metadata function need when you want to select the range. Suppose I select the range, I need only for those images which image is the less than 1% cloud cover. So now it take all of images which are less than 1% cloud cover. In this time, here I find out total 20 images. And these 20 images always less than 1% cloud cover. Okay, so as well as we also put the another function, it's called the sort function. It also important for that, filtering the image properties. Suppose I simply put here the sort function. I sorting this image collection according to the cloud pixel percentage. Okay, just I use this name, cloud pixel percentage. And then click to the run. In this time you can see, in this time, it show the 48 image collection. Okay, when I put the sort according to the cloud cover, it show the result, it show the 48 image collection. So what's the difference between the filter metadata and sort? Basically, filter metadata function provide you the specific range. Suppose it show you that less than 1% all of images. We can get the less than 1% is that 20 images. But when I sorting according to the cloud pixel percentage, I get total 48 image collection. Okay, and after sorting, when you put a boolean operator, it's called the false, then all of cloud will be removed. Basically, this 48 image collection, all of cloud will be removed when I put here the false boolean operator. So in this time, I try to make the, suppose in this time, if you want, you can also use the median. So basically, median provide you the middle pixel value of each images and create this composite. In this time, we are not using the median. We are just put the suppose mosaic. Okay, all of image just extract. I just create the mosaic. And further, it's clip with my study area. Suppose clip with the ROI. So now try to visualize this image, what we can get from here. So map.add layer and call the dry image. And also focus the center of this boundary shape file. Map.center object is ROI 10. Click run. So now it visualize this image. So now it visualize, we can get this type of imagery. So let's find out from here. You can see I just simply put here suppose red, green, and blue. custom suppose stressing 98%, and then further apply. So now we can get this type of imagery. Okay. So in this time, you can see when I put here the false, suppose I don't use the false, suppose I remove the false, then you can see what image I can got from here. I will also show you that again. So for that, click the run. And now I want to add the visualization for band combination, suppose red, then green, also blue, 48% stressing. So you can see it's totally cloudy, okay, all of cloud included in these images. But after sorting function, when I use a boolean operator such as false, then it creates this composite using the total 48 images, and all of unnecessary pixel, the cloudy pixel, will be removed from here. And also you can see it show the it not show the proper range, it show the, you can see, very high value. Okay, so it show the high value because here you can see this image already have the some scale. You can see all of band have the same scale. Okay, you can see b1, b2, b3 have the same scale. So in this time I just simply copy the scale value and multiply with that, then we can get the proper range about the wavelength. So just I try to multiply with that. After mosaicing, just multiply with this value. So now click the run. In this time we also get the proper range. Okay, so now let's check the visualization, and I have to set here suppose red, green, and also blue. Custom stressing 98%. Okay, you can see it show the 0.07 to 0.16. So just I apply. So now we can get this type of imagery, and this visualization I want to import in my code editor. So for that I simply import, just copy this visualization parameter variable name and paste after the object name. So this is my object. After that simply put here the visualization variable name, and further I put the layer name. Suppose I put the layer name, suppose image for dry or dry season image. So now it create the dry season image. So further I want to make for the suppose rainy season imagery. So further what can I do? Just I use the same code. Just I simply copy from here. Just simply change the date or also change the variable name. Then it will be okay. So just I simply copy and paste here. And in this time I simply put here that suppose wet image or wet season image. You can put any name. Further it also okay. Just simply put the time period. Suppose I put here that 05 to suppose 10. Okay, and also simply copy and then paste, and further click the run, and also change the layer name. In this time show about the dry imagery, I want to show it as a wet imagery. Okay, just I put this, change this wet. So now it create the two time period image collection. One is that wet season, another is the dry season. Here you can see in the rainy season or wet season we find out this type of cloud. Okay, so basically in the rainy season when you want to take this satellite imagery you must get the some cloud. Okay, so further next class we also discuss about that how we can easily remove this type of cloud. Okay, and you can see the dry season image, it's very clear, so there is no cloud, we can get very clear imagery. But for that rainy season or wet season we can find out this type of cloudy imagery. Okay, but this type of cloud we can also remove from here. Further we have to use the cloud marks function and then remove this type of things. Okay, further we discuss about that. Okay, so in this time suppose I create two time period imagery, and now I want to check suppose what's the water condition, what surface water condition for the two time period. In the dry season, what's the condition, and the rainy season, what is the condition for that water on the surface. So for that, in this time, I just try to apply here for NDWI. Mainly, NDWI is that normalized difference water index. So in this time, from the rainy season image, I calculate the NDWI, as well as also dry season, I also calculate the NDWI, mainly normalized difference water index. And then further, we check about the water. Okay, for the using the thresholding technique, we extract the water for the two time period, rainy season and dry season. What is the condition for the water in the Dhaka city? We try to check it. Okay, so for that, first of all, we have to make the NDWI map in here. So for the NDWI map, I just try to create for first of all NDWI formula. Suppose NDWI, this formula is that basically green band minus near infrared band divided by green band plus near infrared band. Okay, normalized difference water index. So in this time, I just try to apply this formula in the two images, and then further calculate the NDWI for dry season, as well as also calculate the NDWI for wet season, and then check the water body. Okay, so let's go try to use that. So just take a variable. Suppose I put the variable name is that NDWI dry. Okay, then call the dry season image. You can see I already make the dry season image. It is stored in this variable. I simply copy and then paste here. Okay, in this time, for the normalized difference, we calculate between two band. One band is the green, another band is the near infrared band. So when you calculate any index which have only two band, then you just use a function, this function called the normalized difference function. So you can simply search here, what is the normalized difference function? Simply search on the docs tab. Here you can see normalized difference function. When you calculate that only for the two bands, suppose you can see compute the normalized difference between two bands, any kinds of index which have only two bands, you are just use the normalized difference function. Okay, and you can see it computed as first band minus second band divided by first band plus second band. Okay, so in this time I simply use the normalized difference function and calculate this index. So it's the one way to compute the index which have only two band. So there are a lot of index you can also find out which have only two band. It can be NDWI, you can also calculate, or also NDWI, mainly normalized difference build up index. Okay, or NDWI, normalized difference water index. This type of index we can, which have only two band, just apply this normalized difference function all time. So in this time I simply copy this function, and further I just put here this function and put here the first band and second band. Okay, so in this time, what is the first band? First band is mainly for green band, so B3. And what is the second band? Second is the green band. Sorry, near infrared band. Near infrared band is the B8 for sentinel imagery. So in this time, when I put here the normalized difference function, then it automatically computed as a B3 minus B8 divided by B3 plus B8, mainly green minus near infrared divided by green plus near infrared. So this is the normalized difference function. It's the built-in function. Any kind of index when you calculate which have only two band, just you put the normalized difference function and work with that. But when you work for the other index, suppose which index have the more than two band, okay, and some also have some constant value or some different types of variable, then what we can do? So further I also discuss about that, how can you calculate this type of things. But normalized difference is capable only for the two bands. Calculate any index which have only two bands. Okay, so now I try to add this. Suppose I simply use here map dot add layer and call the NDWI dry and click run. So now it show me the NDWI map of the dry season. Okay, it loaded. Okay, you can see it shows a grayscale color. Okay, it shows a grayscale color. So in this time, I have to add the color for looking more better. So for that, I add the visualization. So for that, I simply make a dictionary. So for the dictionary, we have to use here the curly bracket, and I put here the mean. Suppose it will be start from that -1, and also put here the maximum. Suppose I put it the 0.5, and then further I put here the plated function. Plated, in this time I put the color plated. Suppose I put the red, greater than I put here that yellow, greater than yellow I put here the suppose green, and for the positive blue or high positive blue show as a water, it show as a blue color. And I put the layer name, suppose it's a dry NDWI. So now click to run. Okay, so let me okay, basically this problem for the networking issue. Okay, now it work. Yeah. So I can see it show this type of map for the dry season NDWI. Okay, so now further I want to create for the wet season or rainy season NDWI, and then check for the condition for water body. So just I use the same code, just I simply copy from here and then paste. Okay, so now I call the image of wet season because I have to calculate for the wet season NDWI. I simply paste here. And further I put here the variable name. Suppose I put the variable name, it's a NDWI for wet, and then further copy the variable name and paste here. Okay, so then I put here this same, I simply put the it's a wet NDWI. So just put here that wet NDWI. So now click to run. So now it show the result for dry season as well as also summer season. What is the condition of NDWI? Mainly normalized difference water index for the 2 time period. Okay, so here you can see now it show the result. It evaporate. So here you can find out the 2 layer. Here you can see it show the NDWI rainy season and also NDWI for the summer season. Okay, so now we can get the what's the difference between the 2 time period for NDWI. So here you can see it, this image show for that NDWI for the dry rainy season. Okay, or rainy season we can find out the lot of water body pixel. Here you can see it show the water body pixel in here, and further here you can see that it's the dry season. Okay, so you can see there is no water body in the dry season. Okay, but you can see this is the rainy season, you can find out the lot of water body pixel increasing, but dry season there is no water body, this type of region totally dry. But for the rainy season you can find out this type of place have lot of water body, we can get this type of result. You can see these 2 map we created, one is that dry season, another is the rainy season. So now I want to calculate, suppose how much water body area increase in the rainy season. Okay, I have to calculate the area, how much water body area increase in the rainy season. Okay, so here you can see in this time we are applying the thresholding technique. Okay, and thresholding technique, so basically in this time we have to check some place about their pixel value, and based on the pixel value we just set a condition, and using this condition we can identify the rainy season water. So let's go try to discuss. So in this tab here you can see I just click on the inspector tab and then click on any water body. Suppose I click on here. Here you can see what's the pixel value I can got for this specific coordinate. So here you can say I can get the result for the rainy season or wet season. You can get the 0.3. Okay, 0.3, it means that it's a positive value. Okay, so it must be water. Okay, but you can see for the dry season or summer season, it show about the negative value. It means that there is no water. Okay, in the summer season, but rainy season you can find out the water. 0.3 pixel value. So now let's check more pixel. Suppose I click on here. And you can check the result. You can see we can get the 0.3 and also you can see the 0.1. Okay, 0.1 means that it positive value, not much big positive value. Okay, so you can get the rainy season 0.3. Also check the more point. Okay, suppose click on here. You can get the 0.2. As well as if you want, suppose I want to calculate what is the maximum pixel value for NDWI in the rainy season. I have to calculate it. Then we can easily get it. What is the maximum value for NDWI in the rainy season? So let's go calculate it. Calculating the maximum pixel value of NDWI. And then we just try to add a thresholding equation, and then we can easily extract the water body for the rainy season. So calculating maximum NDWI pixel value in suppose rainy. So for that, for calculating this maximum pixel value, I just take a variable name, suppose max NDWI. And now here you can see I simply call this rainy season NDWI image. So this is the rainy season NDWI where, so basically this variable is stored at this map. Okay, so now from this map I want to identify what's the maximum value of NDWI pixel. I simply copy and then paste here. In this time we use a function, this is called the reduce region. Okay, so basically reduce region, this function always help you to calculate any statistical value. Suppose you calculate what's the average, you calculate what's the maximum value, what is the minimum value, what's the standard deviation value. So any kind of specific statistical value when you calculate in a specific boundary, okay, then you have to use the reduce region function all time. So if you want to get the more details, suppose simply copy and just put in the documentation file, then you can get about the more details. You can see, so reduce region function, so apply reducer to all the pixel in the specific region. Okay, so suppose in the Dhaka city is a specific region, so now from this region I want to calculate what's the maximum pixel of NDWI. So for that I use here the reduce region function. Okay, also you can see this is another function, reduce region. So further we discuss later about the reduce regions. And in this time we talk about the reduced region to calculate for a specific boundary any statistical value. We have to use here the reduced region. So now let's check about all of argument, and then I want to make a dictionary. So curly bracket start and also curly bracket end, and further reducer. So reducer, I want to put here reducer, suppose ee dot reducer dot max. I want to calculate the maximum, so use that the max. And further geometry, geometry is a shapefile variable name which is ry. Scale in this time put at the 10 meter, and it's I remove that not net in this time I remove that. So now further I just simply print that. So print this value max NDWI, copy and paste. So now click to run. So now it computed what's the maximum value of NDWI for the rainy season. Let's check the result. Here you can get the 0.5. Okay, so for my rainy season NDWI map, here I find out the maximum value of NDWI is the 0.5. Okay, so it's my highest value of NDWI, maximum value of NDWI 0.5. Okay, as well as I also try to check about that what is the minimum value of NDWI in the dry season. Okay, what is the minimum value of NDWI in the dry season? Or if you want, suppose I want to check about that from here, just I simply change the variable. Suppose I just copy NDWI dry and then paste here. Just change it the variable name. So now it calculate what is the maximum NDWI in the dry season. So let's check about that. So now let's check the value. We put the value for the maximum NDWI value. We can get the 0.3. Okay, for that in the dry season. Okay, for the dry season, we find out the value 0.3. It is the maximum. Okay, and for that rainy season, we find out the 0.5. As well as suppose I want to check about the minimum value. So for that, you can simply put here that MIN mean. So now it show about that what is the minimum value of NDWI in that dry season. So you can check. We can get the negative 0.62. Okay. Suppose I want to check what is the minimum value for that NDWI wet season. Simply change and click to run. So now let's check from here. You can simply click on here. You can see you can get that NDWI wet season negative 0.60. Okay, so in this time, after checking this all of pixel, in this time we are just applying the thresholding technique. Just suppose I take a variable, I put the variable suppose rainy season water, and in this time we talk only for the positive number because negative number is not a water body for NDWI. NDWI value only can be positive pixel. Positive pixel value identify the water, and negative is identify other types of feature. It can be vegetation or other things. But in this time, our main concern about that water body. Okay, so that's why we are just talk about that positive number, not negative, because negative is not the water body or water pixel is not negative. Water pixel must be positive for NDWI index. So now let's check. In this time, I simply call the NDWI wet season. NDWI wet season greater than 0.2 and NDWI dry less than 0.2. Okay, so you can see here in this time for the rainy season water, I choose all of pixel which is greater than 0.2 from rainy season water, rainy season NDWI, as well as also all of pixel which is less than 0.2 from NDWI dry season. Okay, so in this time I choose the rainy season water. You can see about the condition. All of pixel of NDWI which is greater than 0.2 and also NDWI dry season less than 0.2. Okay, so using this condition, I choose all of this the rainy season water. And basically this type of things we have to calculate. We have to identify based on the some pixel. You have to check some pixel as well as you can also check some maximum minimum value of your NDWI or any other things. When you want to apply the thresholding value, you just try to check about that. What is the maximum value? What is the minimum value? Then you are just put the thresholding equation, this type of equation. And it also helpful to making the flood mapping. When you want to do for the flood mapping, suppose Sentinel-1 or Sentinel-1 imagery, then you have to check what is the value for the VV or VI band, and then you are just applying the thresholding technique and then detect the flood water body. Okay, so in this time I want to show it. So in this time I choose all of pixel which is greater than 0.2 from NDWI wet, and also all of pixel which is less than 0.2 from NDWI dry season, I consider as it's a rainy season water. And further, I want to display this result. So for doing these things, I just take a variable. Suppose water, and I call the rainy season water. This variable I simply call and put here the update marks with this condition. This condition is mainly this condition. Update marks with this condition. Okay. And further, I want to display this result. So for that, map dot add layer and call the watermarks. I want to show this water body as a blue color. So put here that blue, and I put here the suppose it's a I put the suppose water. So now click run. So now it's showing all of water pixel which is greater than 0.2 from NDWI wet season and also 0.2 less than from NDWI dry season. It show about the all of water pixel. So now we try to find out this layer. So now we can see here from here, suppose. So I can see it show about this type of things. It show this type of water pixel which is greater than 0.2 from NDWI wet season and less than 0.2. Suppose I just click any one pixel. Suppose I just click on here. Here you can see the result about that. You can see it show that NDWI and dry NDWI we can get that less than 0.2. You can see this value negative 0.4 is the less than 0.2, and also you can see the NDWI dry we can get the 0.29. Okay, so greater than 0.2 about that. So any water pixel you can check about that. It maintain our equation. Okay, all of pixel, all of water pixel, it maintains our equation. Here you can see we can get the negative 0.4 which is less than 0.2. We can get the 0.32 which is greater than 0.2 from NDWI wet or rainy season. Okay, so now if you want you can also calculate the area. Suppose how much water area we can get in here, the time series chart, then you can also get the more better idea about that. Okay, so any question or any confusion for the previous class? Okay, so if there is no question, then today's session will be in here, and further next class will be held in the inshallah about that. Okay, so issue for in importing file. Okay, so which file you want to import? Is it shape file or CSV file? What's the format? Okay, if possible, you can also share your screen and then show your problem.
So I'm actually so here is the problem. Yeah.
Okay, just if possible, simply share your screen or also show your problem, then we can easily get it. So basically when you want to importing the shape file, we have to select the total 4 file. One is that .ssp, then .hsx, then .dbf and .prj. Okay, when you export when you importing any shape file, simply select this 4 file SSP, SXS, DVF and PRJ and then import, then it will be work. Okay.
Sir, as you said earlier, I will use the 4 code you said, and I downloaded the file from Diva.js. But when I upload it, the table for administration boundary 2.
Yes.
The table is not full, and it shows some problem. I am actually facing problem with sharing my snap in WhatsApp.
Okay, so in this time you want to import the label 2 shapefile. So for that, for the label 2 shapefile, you will just simply import the SSP, SXS, PRG and DBM. These 4 files, select and then import that. Or if you, it also better, you can share your screen and then I'll show you. You try to import that. Then if you face any problem, then I'll also guide you. Okay. If possible, simply share the screen and then open the Google
Sir,
Earth engine.
actually, I am doing the class in my phone, and so I can't share my screen with you.
Okay, no problem. Okay. So after completing this class, you can just simply make the screenshot of your problem and send me or send our WhatsApp group. Then I will easily identify what's the problem you can do, and I also guide you. No problem. Okay. Okay, so I will give you the okay, inshallah, I will try to uploading these things for tonight. You can easily get it, no problem. Okay, no problem. I will try to upload it for the tonight. Okay, no problem. Okay, so is there any question? Okay, so if there are no question, then we'll be in here. And further, next class we take the same time, inshallah, and then try to discuss about the lot of problem. In the meantime, it also better when you face any problem, when you want to show your own screen, then I can easily get the problem and get the solution about that. Okay, so next day we'll also meet and then try to discuss about the further topic. In the meantime, I will send you the recorded class and also send you that all of those things. Okay, so today is no more. Thank you for joining, everyone. Okay, have a good day or night. Okay, bye. Want to join this online training program on Google Earth Engine for 7 days, so you can simply complete your registration. For that, you can simply contact in this WhatsApp number, as well as you can also contact with this email. So I already add all of those things in the video description. Then you can simply check it and then you can easily join our upcoming batch online training program. So basically this class will be start from then 17 May and admission last date is the 15 May, and first 10 registered people will get the 50% discount on this online training program. And basically in this online training program, you will learn all of those things which you need to start the journey with Google Earth Engine platform. If you have no knowledge about the coding, mainly JavaScript or Python, don't worry about that. In this online training program, you are able to learn all of those programming languages such as JavaScript or Python. So here you can see I already added all of those course content, mainly what you will learn after completing the total 7 days online training program. If you want, you can also check all of details from my video description. I already added all of things in my video description. So when you want to join this live training program, you can get some benefit after submitting all of assignment. You can get the course certificate. You can get that all of materials, mainly slide, PDF. You can get all of practice code. Okay. And you can also get the recorded class. Suppose if you miss any live training session, you can easily cover using the recorded class, as well as you can also get the lifetime teaching support. It's very important as a beginners, because when you want to face any problem regarding any issue in your code, you can get the lifetime teaching support. Okay. So if you want to join this live training session, you can simply contact in this WhatsApp number, as well as also contact with this email and get the 50% discount. So book your seat as soon as possible. After booking your seat, you can able to join our Google Classroom and also join our WhatsApp group. So thank you.